Hello and welcome to the 17th video, or I should say the 17th topic in this series. Today we're looking at networks. So let's get started. There's a lot of information in this video, taking me absolutely ages to make this because there's so much information to cover and it's slightly difficult to try and fit it into one video. So a lot to cover. Take breaks if you need to, pause it, make notes if you've got time, but a lot of this is almost certainly going to come up. So first of all, let's just define what a network is. So a definition you can use: computer networks are connections between nodes. And then what a node is, the specification doesn't mention the word node. You may hear the word node in other areas like physics, especially when you talk about waves. But nodes in computing are devices attached to the network. For real definition of node is, they're sort of just devices that can transfer, can have data sent to them and can send data away, but I'm not going to define that specifically because I don't think you need to know it. But it's a useful word to know in this context, which is why I've included it, and I may reference it later. So basically just networks are connections between devices you can use instead that allow data to be exchanged. And we're going to look at two types of networks. The next video is all about the internet, and so we're going to talk about wide area networks a lot more then. So a local area network, or a LAN, is a network that connects computers that are close to each other. And that may seem like quite a sort of like a loose definition, and it's difficult to determine what that is. Is it 10 meters? Is it 20 meters? Is it a house? Well, it doesn't really matter. A LAN is just a smaller network, so it could be a house, it could be a school, but generally it is in a short proximity to each other, so the nodes are close by. And that's opposed to what is known as a wide area network, a WAN, and this is a network over a much broader area, such as the internet, like I mentioned, and occasionally, well, not really occasionally, but WANs often utilise telephone lines that may run under your road, but I imagine that's slightly outdated because telephone lines aren't the only medium used to transport data in WANs nowadays. And it's important to realise that WANs can be made up of individual LANs, such as the internet. The internet is lots of different LANs together. And we're going to look at some advantages and disadvantages to networking a standalone computer, a computer not connected to a network, into a local area network. So not the internet specifically, but just a network, possibly in a house or a school or a work office perhaps. So firstly, an advantage is that a workstation computer, so I'm going to use the term workstation. Workstation generally means that it's in a network, it's in a LAN. It also can mean that it shares the same operating system, but that doesn't apply so much for this video. So a workstation computer can share files and data with other computers in a network it's connected to. So it means that files and data can be easily transferred between the computers. And also resources like printers can be shared and accessed by each workstation. So you don't need to have, with the example of a printer connected to each computer, you could just have one on a network and you can send data to the printer and it will print your stuff from all the workstations or other devices on the network. And finally, linked to the first other 2 points, often they'll have what is known as a server. We'll define that a little bit later, but data is often stored and backed up on a server, and this means it can be accessible by any other workstation on the network and there's less chance of it getting lost, but this isn't necessarily the case for every LAN. Two disadvantages then, because of course there are going to be disadvantages. One of them is that LAN network computers are more susceptible to security issues. The only really way you can breach a standalone computer is by going up to it physically. You can't access it from any other location because it's not connected to a network. You'd have to actually go and use the physical computer to access any files on it. Whereas systems in a LAN, there are other ways to access the data on it. So viruses can spread between networks, and or I should say within networks, and computer systems can be hacked. So security issues are more paramount in LANs, but we're going to look at some solutions to security issues a bit later. Unfortunately, this video I follow it almost exactly in the order the specification says, and it's difficult, and I'm going to have to keep going back and forth between stuff, which is slightly annoying, but it's how it's being done. So a second disadvantage is that hardware required to connect to a LAN can be expensive, and depending on the size and complexity, specialised technicians may be needed to maintain it. We'll look at the hardware in the next slide, but before that, let's just define something called a network packet, or just packet. And what they are, they're small amounts of data sent over a computer network. So when something is transmitted through a network or over a network, it's sort of split up into these smaller little packets, more manageable chunks to be sent to the final destination. And at the final destination, the individual packets are reassembled to form the whole message. It's just a way that data is transmitted, and we're going to refer to this term when we look at network hardware. So in order to connect a standalone computer into a LAN, like we mentioned before, you need extra hardware. You can't just, doesn't happen magically. So here's just an example. We've got two computers here. This is a server and this is a printer. And you have here a little box, and this is called a switch. And you could perhaps potentially in this LAN have these four devices connected via, these could be Ethernet cables, these are Ethernet ports on the switch, connected to this switch, and the switch could be connected to a wireless router, again through an Ethernet cable perhaps. And then the wireless router could be connected to the internet, so this is where the network becomes a WAN, but before this point it's a LAN. And then you may have other devices on this network, such as phones, tablets, laptops, and these are connected with Wi-Fi. The wireless router, as we'll look at in a second, has a Wi-Fi access point in it, allowing devices who have wireless adapters in them to connect to it. And this is just an example of a client-server network specifically. Again, we'll look at this later. I keep having to do that, but this is just an example. This could be in your house, this could be a school, this could be a small bit of an office. It's just an example. And we'll look at a couple of these actual bits of hardware in more detail now. First of all, let's look at a switch. You may be unfamiliar to what a switch is. I have one in my house, but most people probably won't. That's just the setup I have. But switches have lots of Ethernet ports to connect other devices in LAN. So their role is really just to connect devices. And what it does, you may be able to ascertain from the name what it does, but it forwards the packets to the intended destination. So data comes into it from a device, and it sends it away to the device it's required to go to. And the way it does this, it uses what's known as a MAC address on each device, or MAC address. I don't really know how you pronounce it, I've only ever seen it read, but I assume it's MAC address. And what a MAC address is, it stands for Media Access Control Address, and what it is basically a unique identifier each hardware device on a LAN has. So each device, as we looked at before, so for example a laptop, will have a MAC device, more specifically a network adapter in them. Again, I'm going to define this in more detail later, but if you can think of every device having a unique address, it's like an address on a letter. The switch can read this. It's really clever. It learns the addresses and forwards it based on the addresses given to it in the data packets. Data packets are sent with metadata, basically more details about the packet. It's not just ones and zeros. There's other data attached to the data. Metadata stands for data about data, that's what it means, and it can learn the MAC addresses and forwards the packets to where they need to go. And this is opposed to a hub. This isn't like a BT hub. A BT hub is just a name they give it. An actual hub, a repeater hub, to give it its proper term, is sort of like an older version of a switch. And it also connects everything together. You can see the images are incredibly similar. I've done that deliberately by the same company. This one actually has less Ethernet ports, but that doesn't actually mean much. It's just the individual model. But here, the packets of data are sent to everything, not just the intended destination. It doesn't make use of MAC addresses. It just sends it to every device apart from whichever sent it, and it will eventually get to it. But of course, this is less efficient and less private. So, which is why switches are used, 99 times out of 100 over hubs nowadays. Next one I'm going to look at is a router, and a router forwards the packets So it's similar. I mean, you could maybe think it's similar to the switch, but it's slightly different because it makes sure it passes data through different networks, and a router may be used to forward packets from the LAN to your internet service provider and then onto the internet. So what it does, again, it uses similar technology to a switch, but it also learns the fastest way to get to certain places, and it basically connects with other routers. The internet, as we'll look at in the next video, is just a connection of routers passing packets to each other. And then you have what's known as a wireless access point, a AP, and this device is it just allows connection to a wireless network, a wired network, I should say. So you have this network that's wired. This device allows other devices to connect to it using Wi-Fi, and it can be standalone, like this is actually just a standalone access point, or it can be part of a router, making it a wireless router. Okay, let's now move on to looking at two different types of networks, or two different ways of describing networks. The first of them being a client-server network, and no prizes for guessing what this is. It's just a network that consists of clients and servers, and you may have come across these before. We mentioned a server earlier, and you sort of have to define both of them in tandem. You can't really define them individually because it doesn't make sense. They really rely on each other. The server is simply a provider of a service or resource, a resource being like a peripheral device like a printer, and a client is just a requester of this service. In this topology, this little diagram, we have our clients on the outside connected perhaps with Wi-Fi if you add extra hardware here, or through a cable, to our server in the middle. So in this network, every computer system, every node has the role of being either a client or a server, not both at the same time, either a client or server. Very important to realize. So what happens is the client establishes a connection with the server over the network, and an example of this happening not in a LAN but in a WAN. When you connect to the internet, your web browser, Google Chrome, Internet Explorer, is the client, and when you access the website, it connects with the site server, and the server provides a resource which is the web page content. So that's how it gets delivered to your computer, but we'll look at the internet in more detail in the next video. So the main advantage to having a client-server network is that the server can often back up data for you and stores it centrally, adding increased security in a way, although servers are quite expensive and often you need a specialist technician to run it because they are difficult to use. They're not normal computers, they use different operating systems, and an everyday person probably couldn't run a large network using a server. Looking at the second type we've got to know about is the peer-to-peer network, and instead of having a central connection point, a central server, the computers connect with each other, which is what peer-to-peer means. So like I said, it's got no central server. Instead, each computer is equal in responsibility. So here in the client-server network, the server has the most responsibility. It can sort of control the whole network, whereas in here, each computer has equal responsibility. And each computer has the ability to work as both a client and a server, not just either. And so some Wi-Fi networks, maybe not all Wi-Fi networks, use this configuration, and some internet services such as Bitcoin's in the news a lot. You probably won't have used it, but Bitcoin's in the news a lot. It works by connecting people peer-to-peer, and BitTorrent also uses this technology, where instead of files being stored on a server, they're sent with little packets from lots of different computers to each other, and this is often good for extra security. I know I mentioned it here, but in terms of being anonymous, this is a lot better because it's harder to trace. So moving on, we're going to look at three different types of what are called topology. And what a topology is, it's simply another word of saying the arrangement of the nodes and connections in a network. And you've got to get comfortable with referring to it like this. The first of which we're looking at is called the bus topology. So what a bus is simply just a cable, and in this case, this main bus is this central cable here, and you have in this diagram a few workstations, a server and a printer. What happens is all of them are connected to this one cable, this one bus. A bus is just sort of a general term for a cable in computing. And when one of these wants to communicate, the data is transmitted down the bus to all the other connections. So the message gets travelled down to all of the other connections until it hits the end where you have a terminator, and that just stops it bouncing back and forth the whole time. So everything gets the message, but the only one that's expecting it actually processes it. And you don't need to know about advantages and disadvantages specifically, although if I was writing an exam paper, this would be a good question because it sort of uses your initiative a little bit, but I think it's quite a good way of explaining it in a more clear way. So the main advantages of this network is that it's very cheap and easy to install because not much cable is needed. This bus, I mean, obviously the bigger the network gets, the more expensive it will be, but this cable is actually not that much compared to the other topologies we'll look at. But there are obviously quite a lot of disadvantages if it's so cheap. If the whole bus fails, if this one cable fails at any point, the whole network will fail to communicate. This this bus is absolutely integral to the network working, otherwise the devices just can't connect. And another issue is, as this network gets bigger, the performance of the whole network will decrease because you have what are known as data collisions. It's a bit like resistance in a wire with electricity. The data sort of gets lost. It's like a traffic jam. The whole network grinds to a halt when you have so much data going up and down it that the performance just decreases. So it's optimized at a lower amount of devices connected. And also all workstations see all the data, so there is a security risk heightened. The next topology we're going to look at is the star topology, and in this topology it has a central connection point. It looks very similar to the client-server network picture we looked at before, although it doesn't have to be the same thing. Here we've got a hub or switch, or just some kind of central connection point, and it could also be a router perhaps. And most home networks will use this topology because each node is linked to the central connection point, and the connection point sort of runs the whole network in a way. So again, advantages and disadvantages. And advantage is that they're quite reliable, because if one bit of cable here goes, only this device will be affected. Obviously if a device is trying to send messages to this workstation, it won't ever get there, but the other devices can communicate without issue. Also, they're quite high performing. No data collisions occur because all the data is not getting mixed up. It's going through this hub or switch or router. So they're fairly high performing. However, they are quite expensive. A lot more cables are needed, and hardware. The central device is quite expensive usually. And also, a major disadvantage is if this central connection device fails, then the whole network will fail. So that's quite important. Next one we're looking at, and the last topology, is the ring topology. And as you'd expect, it's in a ring shape, so it hasn't got this central connection point. Each device is connected to two other devices, which obviously forms a ring. And when a message is sent in one direction and received by each device. So if this top workstation is trying to send a message to the printer, it will work its way down the cable into this computer, through it, and then to the printer. And if the further away the devices, the longer it will take, and more devices will receive the message. Again, let's look at advantages and disadvantages. Advantage being data is transferred quickly because it only flows in one direction, so there are definitely no data collisions. However, if any of the cable fails or one of the devices is faulty, if one of these devices is faulty and can't transmit the message, then the whole network will fail. And often workstations will see data they're not meant to see, and again there's a bit of a privacy or security risk there. Right, let's move on to defining some key terms. These will get you lots of marks in an exam if you understand them, so make sure you go over it if it doesn't make sense. But first of one we're going to look at is protocol. And this is something that confuses people quite a bit, but protocols in terms of networking are rules that define data transmissions. So the way I like to think of it, well, it's sort of how it works, but if you've got a network here, you see it's made up of all these different devices. You've got a laptop, we've got a phone, we've got an iPhone, maybe a BlackBerry. They're made by different manufacturers in different countries, they might use different languages. They need to be able to agree on certain ways that data is sent to each other, because if one of them was sending data in one way and the other one couldn't receive it in that way, nothing would get transmitted because it just wouldn't work. They're not humans, they can't negotiate without use of protocols. They do something called handshaking, which is negotiating, but they need protocols to be able to define the data transmissions, because otherwise errors would just occur so often that nothing would ever get transmitted, nothing would communicate, because they would all be sending data in different ways, and that just wouldn't work, which is why protocols are so important. And the protocol, if they follow a protocol, it just means they follow the rules that the protocol sets out, and there are hundreds of protocols for different things, and if a device doesn't follow a protocol, if two devices don't follow the same protocol, issues will occur. And the next term that sort of uses protocol is IP addressing, and this is just the assignment of what is known as a IP address or Internet Protocol address. And you probably would have heard of this. Everyone has got a unique IP address. Everything has this unique identifier on a network, and it's a bit like an address on a letter. And networks like the internet use the protocol TCP/IP. That's the protocol set that defines IP addressing, and it just means that devices send packets based on based on the destination IP address. And it's important to realize that IP addresses are unique to a network. So in a LAN, every node has got a different IP address as it is on the internet. However, they can be changed. You can change your IP address as often as you want, and that contrasts slightly. Well, it contrasts with a MAC address. We looked at this slightly before. Media access control address, and they're, like we said, unique identifiers each device on a network has, and they're manufactured into every single network card. And this is just a piece of hardware that allows network connectivity. This is just an example of a wireless network card, a wireless adapter. You may hear them, and so they're manufactured into it. So often they'll be stored in ROM. For MAC address, you have a little bit of ROM. We looked at ROM before. It's just read-only memory, just a little bit of memory, and the MAC address may be stored in it, and you can't change it. You can't change it like an IP address, and they're unique in the world. Every device, in theory, has a different MAC address, whereas here, a device in one LAN could have the same IP address as a device in another LAN, although not if they were in the same network. So IP addresses are slightly more lenient than MAC addresses, but both are used for similar functions. They're used as a destination to send data. Okay, moving on to looking at some sort of ICT stuff. First of which, we're looking at network security. Obviously, it's very important to have some sort of security on a network, and there's a few ways that technicians and managers can do this. First of which is by using user access levels. And these are just sets of permissions users have on a network. So usually in maybe your school or if you work, the ID of you have an ID to log into the network, and it will let you do certain things associated with the ID. There'll be certain permissions, and this means that maybe you can access certain files that someone else can't, or vice versa. And this just prevents people accessing stuff they shouldn't be able to, because they're not senior enough, they're not allowed to, etc. And most networks will have some kind of user access level involved. Next of which, you can also have password protection, hopefully fairly obvious. And this just means that passwords must be entered before certain data is accessed or certain things are done on a network, and this prevents sensitive and private information being accessed within the network, or even perhaps it stops you changing certain network settings, which would be quite bad. Also, you can have some kind of encryption on a network, which helps security enormously. And encryption is just encoding data, sort of jumbling it up often so that it makes it unreadable, and meaning that only people that have been authorized to see it can access it. And encrypted data needs a encryption key to make it readable again. And encryption keys often, so for banks, they often multiply lots of massive prime numbers together. Lots of ways they can make encryption safe, and you need a key to be able to decode it. And the nodes that communication with encryption agree on the key before it's done, and before it's transmitted, and before it's decrypted. So the code's agreed between the two nodes that are communicating, meaning that only they can access it. So that's encryption. Moving on to looking at some network policies, and these are just sort of plans people who operate a network have in place for certain situations. First of which is called the acceptable use policy, and this is basically that a network will have sort of terms and conditions for people using it. So these are just terms and rules of use enforced by the operator on a network. So often if you use a network for the first time, if you join a school or join if you start working somewhere, you have to sign like a little contract to say you're not going to hack the network, or you're going to steal data, and that just sort of like a legal way of making sure that you can be sued if you actually do something like that. Second one is disaster recovery policy, and this is just something. It's just a plan in place in case something goes wrong. So if there's a fire, they'll often have a backup, or if you have an online attack, they'll have a backup of data. That's often covered under what's called a backup policy, just where they have some backup in case of a disaster. You also have something called a failover recovery. This is maybe slightly harder you may not have heard of it. And a failover policy is just for if a piece of key hardware fails, there will be a backup available. So if like a server fails, there'll be a backup server that will just automatically run while the other server's down, which just prevents the whole network going down just because of one bit of hardware failing. So it's just backup hardware that's set so that it will start if the other one goes wrong. Finally, we also have archiving, and this just means that the network people, the network managers, keep archives, and that just is a store of data that's currently not in use but may be used at a later date. So for example, they might have some previous user information in case they come back to the network or something, just an archive that they aren't using at the moment but may use in the future. So that's it for this video. A lot of information, very long, but hopefully it was useful, and next up we're looking at the internet in more detail, so hopefully you'll be able to join me then.